In this lesson, we're going to go over solving linear inequalities. So this is very similar to solving regular equations, except for one thing. If we multiply or divide by a negative number, then we have to flip the inequality sign. So a sign like this would be changed to the other way. Let's look at an example. If we have 2x minus 5 is less than 3. Okay, we're just going to treat this like a regular equal sign when we solve. So let's just draw a line down the middle. First thing I'm going to do is add 5 to both sides, because we want to isolate the x. Left with 2x is less than 8. Now from here we have to divide by 2 on both sides. Then we end up with x is less than 4. So this could be our answer. If we have to graph it, just draw a number line. Have the number 4, number 5, 3. The circle goes at 4. It's less than, but it can't equal it, so it's an open circle. And it's less than 4, so we make a arrow going in this direction. Alright, if we have negative 3x plus 7 is less than 1. Again, we're going to treat this like a regular equation when we solve for x. So we'll just draw a line down the middle again. Alright, so negative 3x plus 7. First thing we have to do is get rid of the 7. So now we have negative 3x is less than negative 6. 1 minus 7 is negative 6. Okay, but at this point we have negative 3x is less than negative 6. To get rid of the x, we have to divide by negative 3 on both sides. Okay, and because we're dividing by negative 3, we're going to have to flip this sign. So this just becomes x on this side. Negative 6 divided by negative 3 is positive 2. And we have to flip this the other way, so we have x is greater than 2. Okay, again, I just want to point out we had to flip this because we divided by a negative number. It doesn't matter that this is negative 6. Even if this were positive 6, if this was positive 6, we still have to flip it. Okay, because we're dividing by a negative number here. And if we had to graph the answer, okay, it's greater than 2, so we got to put our circle at 2. We're not going to fill it in because it does not equal it. It can't equal it. And x is greater, so we draw a line going greater than 2. Alright, so again, solving linear inequalities, very similar to solving equations, except if we multiply or divide by a negative number, we have to flip the sign. And also another difference is that we're not going to get an answer, an explicit answer for x, or an explicit solution for x. It's going to be a range of numbers. So we didn't find that x is 4, or x is 3, or anything like that. X is any number less than 4. Same over here, x is any number greater than 2, all the way up to infinity. Here we have a more complicated inequality. we have two different conditions. 3x minus 2 has to be greater than 1, and also 3x minus 2 has to be less than or equal to 16. This is kind of complicated to do as is. What we should do is separate these into two different inequalities. So we'll do the first part. 1 is less than 3x minus 2. And then we'll do the second part. 3x minus 2 is less than or equal to 16. So we'll add 2 to both sides. We can draw this line down the middle. Here on the right side, the 2's cancel out. On the left side, we have 1 plus 2 is 3. So 3 is less than 3x. Now we'll divide by 3. 3 divided by 3 is 1. So we have 1 is less than x. Okay, now let's solve this inequality. Again, let's draw this line down the middle. We'll add 2 to both sides. The 2's cancel. We have 3x is less than or equal to 18. And finally, to solve for x, we'll divide by 3. So we have x is less than or equal to 6. 18 divided by 3 is 6. To determine how to write this inequality, let's first look at how we would graph it. Okay, so for this part, x is greater than 1. So we have a circle at 1, and x is greater than 1, so it's going to go to the right. I'm not going to draw an arrow yet. I'm just going to start coloring it in. And over here, we have that x is less than or equal to 6. So we have our circle at 6. It's less than or equal, so we have to shade this in because it can be 6. And we'll shade less than. And we see that if we go this way and we go this way, they're going to meet up. So this is our solution right here. So we see that x has to be greater than 1, but it also has to be less than or equal to 6. So we can write it like this, with these as the two endpoints, 1 and 6, and x is in between the two, but it can also equal 6. Alright, so again we have another complex inequality. Let's break this down into two simple inequalities. So 1 is less than 3x minus 2, this first part, and then 3x minus 2 is less than or equal to negative 5, the second part. Okay, let's solve this one first. Let's make our line down the middle, and let's add 2 to both sides, so we could isolate the x term. So on the left we have 1 plus 2 is 3, is less than 3x, that's what remains on this side. So we have 3 times x. To isolate the x, we'll divide by 3 on both sides. Okay, 3 divided by 3 is 1. So 1 is less than x. Alright, now let's solve the inequality over here. Okay, let's draw a line down the inequality sign. And it's going to be very similar to this one. We have to add 2 first to both sides. So on the left we just have 3x less than or equal. And we have negative 5 plus 2 is negative 3. So now we have 3x is less than or equal to negative 3. Divide by 3 on both sides. And we have x is less than or equal to negative 1. Okay, so now when we write this, let's draw our line graph and figure out how we're going to graph it, and then how we can write this as our solution. So we have -2, -1, 0, 1, 2. Okay, so for this first one, x is greater than 1. So we make our open circle at 1 because it cannot equal it. X has to be bigger than 1, so it's going to go in this direction. Okay, now x has to be less than or equal to -1. So at -1, we shade in our circle because it could equal it. Right, but x has to be less than or equal, so less than would be to the left. Okay, when we look at these, we see that they're going in opposite directions. This one's going to the left, this one's going to the right. They're not going to meet up. So let's add arrows here. So in this case, the way we have to write it is that x is less than or equal to -1, or x is greater than 1. So it's not going to satisfy both. For example, -2 is a solution, so that would be less than or equal to -1, but it's not at the same time greater than 1, so it's or. It's one or the other. It's either going to be on this side of the solution or on the right side, one or the other. So when we write it, we can't combine them like we did previously. We have to write or.